Let's look at question 1. The coefficient of x cubed in the expansion of 3 plus 2ax to the power of 5 is 6 times the coefficient of x squared in the expansion of 2 plus ax to the power of 6. Alright, so what do we need to do here? We first of all need to get the coefficient of x cubed in the expansion of that, and then we also get the coefficient of x squared in the expansion of 2 plus ax to the power of 6, and then of course we equate them accordingly as they've said there. So how then do we get the coefficient of x cubed in the expansion of 3 plus 2ax to the power of 5? Remember, we just need to apply the formula here. That will be 5 combination r in brackets 3 to the power of 5 minus r dot 2ax, I have to put that in brackets, to the power of r. That is the formula, okay, of the, if we are to expand that. Now remember, r ranges from 0 till we get to 5. But for us to get the coefficient of x cubed, it means r should be equal to 3. All right. So if our r is equal to 3, then this here becomes 5 combination 3. Okay, 3 to the power of 5 minus 3 dot 2ax to the power of 3. Now if we simplify that, 5 combination 3, what do we get? We get 10. Okay, if we use our calculator, and then of course 3 to the power of 5 minus 3, 5 minus 3 is 2, so 3 to the power of 2, that will give us 9. Multiply by 2 to the power of 3, that will give us 8, and a to the power of 3, that will be a cubed x cubed. All right, so if we are to talk about the coefficient, we only need this part here. All right, so that will give us the coefficient of x cubed. So what then are we saying here? We are saying the coefficient of x cubed, that will be 10 times 9 times 8, that's 720. 720 a cubed. That is the coefficient of x cubed in the expansion of that. All right, and then we move on to getting the coefficient of x squared in the expansion of 2 plus ax to the power of 6. So we do the same. We apply the formula. We are saying 2 plus ax to the power of 6. What are you going to have? We are going to have 6 combination r, 2 to the power of 6 minus r dot ax to the power of r. Now for us to get the coefficient of x squared, it means our r in this case should be 2. Okay, so when our r is 2, what then are we talking about? We are saying here 6 combination 2, okay, from the formula, then 2 to the power of 6 minus 2, that's 4, dot a x to the power of 2. All right, and now if we are to simplify that, 6 combination 2, that will give me 15, multiplied by 2 to the power of 4, that is 16, and then we have a squared x squared. That's what we actually have in there. So the coefficient then, that what we are looking for there is 15 times 16, that will give me 240. Okay, 240 a squared. So that there is the coefficient of x squared. Now, but how are these two related? We are told here that this here, it is 6 times that. So it means we can formulate an equation 720 a cubed is equal to 6 times 240 a squared. That is what we are saying. So from there we can then solve for a. All right, the best would be to, okay, if we simplify that, we are going to have 720 a cubed equal to 6 times 240. That will give me 1440 a squared. Now to solve such an equation, remember we need to take this to this side, and then of course maybe we can factorize. So we have 720 a cubed minus 1440 a squared is equal to 0. All right, so then we can factor out 720 squared, 720 a squared, right? That's the common factor there. So if we have 720 a squared, we're going to have a minus 2 is equal to 0. So we factorized. So what it means there is that this here is equal to 0, or that is also equal to 0. So we have 720 a squared is equal to 0. So a squared is equal to 0 if you divide both sides by 720. So meaning to say that a is equal to 0. Okay, but then we wouldn't want our a to be equal to 0, because then it means that this part here is going to become 0. So we are only going to have 3 to the power of 5. So it won't be really a series. Okay, so what we can then just do is that we just have to, this a is equal to 0 is invalid. We need to find out with the other one. We have a minus 2 is equal to 0. So if we solve for a there, we're going to have a is equal to 2. So the valid answer here is a is equal to 2. A is equal to 0 is invalid. All right, so that's what we have there for question 1. Moving on to question 2. What are we having here? We are told to find the exact solution of the equation pi over 6 plus inverse of tan of 4 of x of 4x is equal to negative inverse of cos of square root of 3 over 2. Okay, that's actually what we are having. So what we need to do there is, of course, this we can evaluate it. If we evaluate it, even using a calculator, we'll be able to tell that actually we are going to have negative pi over 6, because inverse of cos of square root of 3 over 2, that's actually pi over 6. So with having a negative, so it means that whole thing becomes negative pi over 6. That's if we evaluate the right hand side. So we are having pi over 6 plus inverse of tan of 4 of x, 4x rather, is equal to, evaluating the right hand side, we get negative pi over 6. So then we can take this one here to this side. So what are we going to have? We are going to have tan, inverse of tan of 4x is equal to negative pi over 6 minus pi over 6. Okay, so if we simplify that, we are going to get negative pi over 3. All right, so we have inverse of tan of 4x. Now for us to solve for 4x, it means the tan comes this side is tan. We are going to have tan of negative pi over 3. That's what we are going to have. Okay, so we have 4x, because remember this side here is an inverse, so if it goes that side it becomes a normal tan. Okay, so we're gonna have tan of negative pi over 3. Okay, now if we simplify that, what do we get? We are going to get negative square root of 3. Okay, so we have 4x is equal to negative of square root of 3. That's what we are having. So we can then divide both sides by 4. We are going to get our x is equal to negative square root of 3 over 4. So that's a simple equation to solve there. Okay, let's look at question 3. The equation of a curve is such that dy dx is equal to half of x plus 72 over x cubed, x to the power of 4. Now the curve passes through the point P28. Okay, find the equation of the normal to the curve at P. All right, so what we are actually having here, we are having the derivative. Now, of which the derivative, if we were to substitute this x coordinate here, which is x is equal to 2, if we substitute there, we are actually getting the gradient at that point, and that gradient is also equal to the gradient of the tangent. Now, but what is the relationship between a tangent and a normal? Okay, say suppose I have a curve like this, and this happens to be a tangent at that point. All right, and then the normal should then be this one here in blue. So here is the tangent, there is the normal. Now, so what is the relationship that exists between the gradient of this tangent and the gradient of the normal? They are a reciprocal of each other. Okay, they are reciprocal of each other, and of course they should have different signs. As you can see that this one here will be having positive gradient, that one will be having a what? A negative gradient. So what we need to do in this case here, for us to get the equation of the normal, we need to get the gradient of the tangent, okay, at this particular point, which is P in this case. Now when we get that gradient, that will allow us to get to be able to get the gradient of the normal. So with that gradient of the normal and the point, we should then be able to get the equation of the normal. Okay, so that's what we are going to do there. So let me use this notation here. F prime x is actually equal to what we are having here, half x plus 72 over x to the power 4. So I am getting the gradient of the tangent, so I'm going to call it m subscript t, representing tangent. And so how do I get that? I have to substitute the x coordinate. All right, so I have half of what? Of 2 plus 72 over 2 to the power of 4. Okay, so what do I get here? Half of 2, that's 1, plus 72 divided by 2 to the, remember 2 to the power of 4 is 16, so we are having 72 divided by 16. So if we simplify that, we are going to get 9 over 2, which if simplified further, we will get 11 over 2, or rather just 5.5. But since we'll be talking about the reciprocal, it is better you leave it in a fraction form. So the gradient of the tangent at that point there is 11 over 2. So what then is the gradient of the normal? It will be the reciprocal of 11 over 2. That's 2 over 11, but of course with a different sign, negative. All right, so that is the gradient of the normal. Of course, if we use this gradient and the point, we should then be able to get the equation of the normal. So I'm going to use this form, y minus y naught equal to, let me say, gradient of the normal, x minus x naught. So we substitute the point 28. So we have y minus 8 is equal to negative 2 over 11 x minus 2. Now if I'm to simplify that, I'm going to get y minus 8 equal to negative 2 over 11 of x plus 4 over 11. Now I'm going to take this negative 8 to that side. what am I going to get? I'm going to get y is equal to negative 2 over 11x plus 4 over 11 plus 8. What do we have as our answer? Okay, I will have to create space here. My equation of the normal then will be y is equal to negative 2 over 11x plus 92 over 11. Okay, of course I ate up the space used when I was sketching this, so that should be enough, of course, for this space here. Okay, so that's the equation of the normal that we need. All right, then moving on to the B part of the question. Remember, we are given the derivative, okay, dy dx equal to half of x plus 72 over x to the power of 4. Now, if I'm to find the equation of the curve, I just need to integrate this because I'm having the derivative. So the reverse process of differentiation should then be integration. So we need to integrate both sides. Okay, I'm going to integrate this side here with respect to what? To x. Integrate that with respect to what? To x. Now, the integral of this derivative obviously should be y. All right. This side, before I integrate, I need to make sure that both my terms, this term here and that term, they are in the standard form, which is supposed to be a x to the power of n. Now, of course, this part is fine, but this part here is in fraction form, so we need to convert it into this form so that we can be able to integrate without any problem. So I'll have to have this. Okay, this is half x, that's okay. It's ready to be integrated. Of course, remember that is to the power of 1 plus 72 x to the power of negative 4. So that is what I'm actually having there, which I can then integrate. All right, so we have y, the integral for half of x, that will give me 1/4 of what? X to the power of 2. And then we integrate this. All right, we have to add the plus 1 there, we will get negative 3. So then 72 divided by negative 3, we will get negative 24 x to the power of negative 3. Of course, since we are integrating, we should add the constant of integration. All right, but then how do we get this constant of integration there? We need to substitute the point that we are given, which will allow us to get the constant of integration. So we have 2, 8. So if we substitute this into that, we should then be able to get our constant of integration. So let me substitute. So my y is 8 is equal to 1/4 of 2 squared minus 24 over 2 to the power of 3 plus c. All right, what do we have? So we have 8 here is equal to 1/4 of 2 squared, that should be 1, minus 24 divided by 8, that should be 3, plus c. So simplifying this further, we will get c is equal to, remember this is 1 minus 3, that's negative 2. Negative 2 comes this side, we are going to have 8 plus 2 giving me 10. So c is equal to 10. Right, so having the constant of integration, I can then be able to write down my equation, which is y is equal to 1/4 of x squared minus 24 over x cubed plus 10. I would rather leave my answer in this form here rather than having a negative power. And an expression that has got a negative power is not simplified. So in a simplified form, you should convert to a positive power, which is what we are having there. Okay, so that's what we are having for the equation of the curve. All right, now moving on to the next part or next question, which is question 4. Right, I'm sure you can see there that just by looking at what we are having here, we are being asked to get the perimeter of that shape and of course the area. That is actually falling under the topic of circular measure. Okay, so let's look at what we are having here. We are told that the diagram shows the shape of a coin, so that's a coin that we are having there. Now the three arcs AB, BC, and CA are parts of the circles with centers C, A, and B respectively. Okay, so ABC is an equilateral triangle with sides of length 2 centimeters. So let me have something like this. Okay, if I can divide this into, because I'm told that ABC is an equilateral triangle, so that should be 2 centimeters also. This one also 2 centimeters. So since it's an equilateral triangle, it means that the angle, each angle here, they must be equal, and equal at what? Pi over 3. Okay, it should be pi over 3 because that's 60 degrees. But we need to consider the use of radians, so this should be pi over 3. So if I'm to get the perimeter of this, I need to have this side plus that side plus that side. Now if I'm to look at ACB, that's actually a sector, meaning to say that this is actually the length of the arc AB, and we know how to get the length of the arc. If we get this AB, we should then be able to just multiply by 3, because AB, BC, and AC, they are equal due to the fact that the angles are equal and the radius are also equal. So we should have perimeter if we have to add all of them, the 3 of them, or rather having this and multiply by 3. So how do we get the length of the arc? Remember, it's L is equal to radius multiplied by the angle. That should be, the angle should be in radians. So what is my radius? The radius is 2. Okay, so we have 2 multiplied by the angle, which is pi over 3. So that is the length of the arc that I'm having, 2 pi over 3. So then therefore the perimeter is going to be 3 multiplied by L. Okay, so we have 3 multiplied by 2 pi over 3. If we multiply that, this cancels out, we're gonna have 2 pi. So that is what we are having. That is the perimeter of that coin. Okay, now moving on to the B part. We are to find the area of the face ABC, okay, of that coin, giving the answer in terms of pi and square root of 3. Right, please take note that to get the area of that coin, we need to have the area of the triangle, okay, which is the equilateral triangle. And then when we do that, we also need to get the area of, say, this segment here. How do we get that? We will need to have the area of the sector ACB. When we have that area of the sector, we subtract the area of that so that we can get that. But the moment we get that, then we know that this, because we know that this area here, which I've shaded in red, is also equal to that, and it's also equal to that. Okay, so whatever area that we get, we have to multiply by 3 to get the area in red, of course, plus the area that is in blue, for us to be able to get the area of what? Of the coin. All right, so let's start by getting the area of the triangle. So I will say here, area triangle Okay, mind, please excuse my handwriting, but let me try to improve that. So we are saying area of the triangle. We know the formula of an equilateral triangle. In this case, what are we having? Because for that triangle, we have this side and that side, and of course the included angle, which is pi over 3. So in that case, we can use half AB sine C. Okay, you remember that? Okay, that for the formula half AB sine C. Okay, my handwriting is becoming worse and worse, but okay. It's half AB sine C. All right. Which in this case, what is my AB? My A will be 2, and my B will be again 2 there, and the angle sine C, that is the angle, the included angle. That's what we need to use. So I'm going to have it as 2 multiplied by 2 sine of what? Pi over 3. That is divided by what? 2, because we're saying half of. Okay, it's better that I put it in that form. So simplifying that, I'm going to get 2 multiplied by sine of pi over 3. That gives me square root of 3 over 2. So simplifying this, what am I going to get? I'm going to get square root of 3. That is the area of the equilateral triangle. Okay, that's the area of the equilateral triangle. Now let's now get the area of the sector. It's simply by applying the formula. What is the formula of the area of sector? It's r squared theta over 2, of which my radius in this case is given as 2. All right, it's 2 squared multiplied by the theta is pi over 3 divided by 2. So simplifying further, that will give me 2 pi over 3. Okay, so that's the area of the sector. Now to get the area of the segment, that this segment which is in red, we have to say the area of the bigger shape, which is the sector, minus area of the equilateral triangle. Okay, so if I subtract that, I will get the area of that minor segment in red. Okay, so I'm going to say area of minor segment Why am I calling it a minor segment? It's because it's like we are having this circle here, and then we have a chord which is like this. Okay, that is what we are having. So this here is the minor segment. The bigger part there is the major segment. Okay, all right. So if we are saying here to get the area of that, we need the area of the sector, which is 2 pi over 3 minus the area of the equilateral triangle. All right, but remember there are 3, so which means we can multiply that by 3. So the area of the coin should then be 3 times 2 pi over 3 minus square root of 3. So that's the area of the 3 minor segments, plus of course the blue part of the diagram, which is this one here, which is the equilateral triangle. So we are saying plus square root of 3. We got it already. That's what we have in there. So we have square root of 3. All right, I can simplify this further. 3 times 2 pi over 3, that will give me 2 pi, and then 3 times negative square root of 3, that will give me that, plus square root of 3, of which we know that we can simplify this. Negative 3 square root of 3 plus square root of 3. That will give me negative 2 square root of 3. So we have our answer as 2 pi minus 2 square root of 3. That is what we are having. Okay, so that's question 4. Okay. Now let's look at question 5. The first, second, and third terms of a geometric progression are sine theta, cos theta, and 2 minus sine theta, respectively, where theta radians is an acute angle. Okay, so obviously this must be a topic of sequences and series, where here we are talking about a geometric progression. Okay, so we are given the first term, second term, and the third term. We are to find the value of theta. Now remember, if it's a GP, it means we have a common ratio which is equal to T3 over T2. That should be the same as T2 over T1. So that will give us a common ratio. So since we are to find the known theta, we have to formulate an equation, obviously considering this. All right, so what is our T3? Our T3 is 2 minus sine theta over T2 is cos theta is equal to T2 cos theta over T1, which is sine theta. All right, so that is an equation that we are having. Now, how do we solve for theta here? To solve this equation, we have a single fraction on the left hand side and a single fraction on the right hand side. So all we need to do is to do cross multiplication. Okay, so I'm going to have sine theta multiplying 2 minus sine theta. That is equal to cos theta times cos theta. That gives me cos squared theta. All right, let me simplify or expand the left hand side. I'm going to get 2 sine theta minus sine theta times sine theta. That will give me sine squared theta. That is equal to cos squared theta. All right, now take note that we are having two trigonometric ratios here. If suppose I take this one here to that side, cos theta squared plus sine squared theta, I'll get 1. Okay, so I'm having here 2 sine theta is equal to cos squared theta plus sine squared theta. Now we know that cos squared theta plus sine squared theta, this should be equal to 1. So we're gonna have 1 this side here, of course, equal to 2 sine theta. All right, dividing both sides by 2, we're gonna have sine theta equal to half. So for us to solve for theta here, we have to get the inverse of sine of half. Okay, so that is what we are having. So it's theta is equal to inverse of sine of half, and that is actually going to give us pi over 6. All right, now we are told here that the theta is in radians and is an acute angle. Now remember that sine theta is equal to positive half, either in the first quadrant or in the second quadrant. Now in the first quadrant, that's where we are having an acute angle, which is this one here. Okay, so the one that is in the second quadrant, we don't need that. So it means our theta in this case is actually pi over 6. Okay, all right, so we move on to the B part of the question. We are told here that using this value of theta, which is pi over 6, find the sum of the first 10 terms of the progression and give the answer in the form of b over square root of c minus 1, where b and c are integers to be found. Okay, so if we are talking here of some of the first n terms of the progression, which is geometric progression, it means our n is equal to 10. So we are actually to find S10. That's actually what we need to find. Now, but we need to find out our R. Remember our R, we said our R is cos theta over sine theta, that is T2 over T1. All right, so if I substitute my theta there, I'm going to have cos of pi over 6 all over sine of pi over 6. Okay, that the cos of pi over 6, that gives me square root of 3 over 2. Now divided by sine of pi over 6, it's half. So which simplifies to what? Square root of 3. Okay, now square root of 3 is actually greater than 1, meaning to say that this progression here is actually divergent series. So the formula for getting the sum of the first n terms, it's Sn is equal to a in brackets r to the power of n minus 1 over r minus 1. So what is it that we need to for us to get the sum of the first 10 terms? Of course, we need to get our a, we need to have our r, which we got already. Our n, we said it's 10. Okay, so our a, it's sine theta. That's our a. So it's sine theta is pi over 6. So which means my a is half. Okay, and my r is square root of 3. All right, and then my n is equal to 10. So using those, we can have our S10 is equal to 0.5 in brackets square root of 3 to the power of 10 minus 1 all over square root of 3 minus 1. Okay, so sum of the first 10 terms, we are saying 0.5 in brackets square root of 3 to the power of 10 minus 1 over square root of 3 minus 1. So what do we have there? We're going to have 0.5 in brackets square root of 3 to the power of 10. It gives us 243 minus 1 all over square root of 3 minus 1. Now 243 minus 1, that gives me 242 times half 0.5. That would be 121 over square root of 3 minus 1. Now if we look at the answer that we are having here, it is actually in the form of b over square root of c minus 1. So in this case, our b is 121, our c is 3. So that is our answer. Now moving on to question 6. All right, what do we have here? The equation of a curve is y is equal to x squared minus 8x plus 5. Find the coordinates of the minimum point of the curve. All right, we have quite a number of alternatives here. One way of getting the minimum point in this case is we could complete the square. When we complete the square, then we can easily identify the minimum point. Or another method would be to differentiate this function here. And then when we differentiate, remember at a minimum point, the derivative is equal to 0. So we equate to 0, and then we solve for x coordinate. When we get the x coordinate, we substitute back into the function to get the y coordinate. So that's another way. Then the third way would be to use the formula x is equal to x coordinate equal to negative b over 2a. But I'm not going to dwell on that one. I'm going to look at the first method where we complete the square. The reason why I'm preferring to use the completing the square method here is because this is quite easy to complete the square there. All right. So let me have it. Y is equal to x squared minus 8x plus 5. So I have to ask myself, since the coefficient of x squared is 1, in other words, this first part here is 1. So I have to ask myself, what number do I need to have to add to this part here so that we can have a complete square? Now remember, c is equal to b divided by 2 squared. So in this case, my b is negative 8. If I divide that by 2 and square, I'm going to get 16. So in other words, my function becomes y is equal to x squared minus 8x plus 16. So this here is a complete square. But of course, since we have, sorry, that should be 16 there. That should be 16, not 6. Since we have added 16, we should actually neutralize that by saying minus 16 plus 5. So this part here, which I've underlined in red, is a complete square. Of course, we have this extra part. So we're going to have y is equal to, if it's a complete square, which means I can easily factorize it. And to factorize a complete square, we know the bracket should be squared. And then we ask ourselves, square root of x squared is what? It's x. The same sign that we have there should be what we should have there. And then square root of 16, we have 4. So that is a 4 there. And then this part here, we just need to simplify it. That's negative 16 plus 5. That gives me in negative 11. So that's the completed square form of that function. So from there, at a glance, we can easily get the turning point. Let me use M as my turning point, the minimum point. So how do I get the x coordinate? X minus 4 equal to 0. And I saw for x there, I'm going to get x is equal to 4. All right, sorry. I'm going to get x is equal to 4. And then the y coordinate is just what you see there, negative 11. That is the minimum point. Okay. So, but you can choose to use any of the other two methods. All right, so now moving on to B, we are saying the curve is stretched by a factor 2 parallel to the y-axis and then translated by 4, 1. Find the coordinates of the minimum point of the transformed curve. Okay, this is quite easy. So the minimum point of the transformed curve, how do we get that? We need to get the x coordinate first and then the y coordinate. The x coordinate would be, remember the x coordinate to the original minimum point is 4. So 4 is what we are having there. Okay, but then if it is stretched by a factor of 2 parallel to the y-axis, which means this is not affected. So we don't, this 2 does not affect that. But then there is also translation by 4. So which means this 4 is we are going to add 4. Okay, because, so we are going to say 4 plus 4, giving us 8. So that's the x coordinate. And then the y coordinate, what are we having? Remember the y coordinate, the original one is negative 11. So we have negative 11, but since it is stretched by a factor of 2 parallel to the y-axis, which means we are going to multiply that by 2. Okay, but that is not only the only effect. It is also affected by translation, whereby there is a translation of by 1 unit. in the y direction. So we are going to have plus 1. So we have negative 22 plus 1 giving us negative 21. Okay, so the minimum point in that case becomes 8, negative 21. Quite easy. All right. All right, then moving on to the C part of the question, they are saying find the equation of the transformed curve. Give the answer in the form of y is equal to ax squared plus bx plus c, where a, b, c are integers to be found. So remember, if we have a function like this one, y is equal to f of x, all right, if it is stretched by a factor of 2 in the y direction, which means we are talking here of y 2 f of x. Okay, so let's do that stretching first, that transformation first of stretch in the y direction. So remember, we are talking here of 2 f of x, but what was 2 in the completed square form? We said it's x minus 4 squared minus 11. So if that is multiplied by 2, what are we going to get? This 2 multiplies the bracket, because it doesn't open the bracket, it just stays like that because it's logged by the square. And then 2 times negative 11, what do we get? We get negative 22. So that is the function after stretch. And then there's also translation by translation vector of 4, 1. Okay, remember, that is y is equal to f of x minus 4, okay, plus 1. That is the translation, because our translation vector is 4, 1. That's what we have been given. So that's why we are having x minus 4 there, of course, plus 1. Right, so this is our function. So if we apply this translation, it means that okay, sorry, this part here is not negative 2. Remember, this is negative 4. My bad. It remains as negative 4 because these two just multiply that, and so it just should remain like that. Okay, so we continue this one here. We actually apply that. What are we going to have then? We are going to have 2. Now, since on the way there's x, we are going to substitute x minus 4. It means x minus 4 minus 4. We are going to end up having x minus 8 squared. And this plus 1 affects this. So it's negative 22 plus 1. We are going to have what? Negative negative 21. Okay, that's what we are having now. So even from here, you can actually see that the turning point here is 8, negative 21, which is actually what we got in the first part there. Okay, there should be that coherence. All right, so what then are we having here? So this is the function after stretch and translation, but they are saying that we should leave our answer in that form, which means we need to expand off there. So we have y is equal to 2. Can I put square brackets there? If I expand x minus 8, it's x squared minus 16 x plus 64. Okay, minus 21. So simplifying further, that gives me 2x squared minus 32x plus 128 minus 21. So if I simplify that, what am I going to get? I'm going to have y is equal to 2x squared minus 32x plus 107. Okay, So that's actually what we are having. So that is the equation of the transformed curve. Okay, of course it's the same, but we need to leave it in that form. Okay.